Welcome back. Zeroing can be a very controversial topic. A lot of people in the industry have extremely strong opinions about what method you should use and what distance you should do it at. You may hear that you should use the Army method, the 25 meter zero, or you may hear that the 50 meter zero is the new standard, or you may hear that you should use a 100 meter or maximum point blank range zero. Now, what's my answer to this? Those are all standardized zeros. They work great if we're all using the same equipment, and the same ammunition, same bullet weight, same muzzle velocity. The problem is that most of us don't have that. Whether we're law enforcement or civilians, we're probably all shooting different rifles, different ammunition, and different lengths. This all affects our bullet trajectory. So what's my answer to this? You should be using the zero that's best for you, your equipment, your ammunition, and your application. So what I'd like to cover in this section is how I go about finding out what distance you should be zeroing at. Now, before we get too deep into this, we need to cover external ballistics, or what actually happens after the bullet leaves the barrel. If you don't understand what happens after the bullet leaves the barrel, you're going to have a hard time understanding what you need to do to get that bullet to hit a target at distance. Let's look at this first graphic. Generally, it represents uncorrected external ballistics. Now, I'm not a big artist here, so this isn't to scale, but you get the general idea. Now, we've got our rifle over here to the side, and we've got some lines sticking out towards our red target. Now, let's talk about what these lines represent. First, let's just consider that our rifle is generally level to the ground, okay? Now, the black line is our uncorrected line of sight as it passes through the optic towards the target. We haven't made any sight adjustments. Let's just consider that's level to the ground at this point. Then, we've got the blue line. This is our line of bore, or axis of bore. Just consider this as if we stuck a laser beam inside of our barrel and it's pointed out so it shines in a direct line exactly where this barrel's pointed. Just perfectly level to the ground. Then, we've got the yellow line. This represents the path of the bullet. Now notice it's not going straight out to the target. It's not rising. A bullet has no lift characteristics. It doesn't rise when it leaves the barrel. Gravity begins to pull it towards the earth as soon as it departs the muzzle. So, in this graphic of uncorrected external ballistics, the bullet's dropping away from our line of bore as soon as it leaves the barrel. Now, how do we get this round to hit the target? Well, the answer is as simple as if we're throwing a ball. To hit a distant target with a ball, all we do is we aim it up a little bit. The ball begins to fall away from the initial angle that we threw it at, but it arcs towards the target. That's the same thing that we're doing with the rifle. So we're getting it to point up just a little bit, just like in this picture. Notice how the round comes up and back down. Now, it's still dropping. If you notice, it's still dropping away from our line of bore, right? Now, we all know we're not aiming at clouds to hit our target, so how do we get the barrel to do this? Well, the answer is we correct our sights, whether it be mechanical or optical. We're just going to adjust them so it forces us to reference the barrel and point it or elevate it up slightly. This graphic represents what we're talking about here. Now, just for conversational purposes here, we've got some data here representing a 25 meter, 300 meter zero the Army uses. Now, notice we've corrected our sights, angled the barrel so it points up slightly. The line of bore is continuing up, our line of sight's moving directly towards the target, and the bullet passes up through our line of sight until it reaches the terminal ordinate, and then back down through our line of sight towards the target, right? That's generally what's happening here. Now, notice that the bullet starts lower than the line of sight when it first leaves the barrel. That's because of the sight height. The distance that it starts off at is equal to the distance that the sights are over the bore, and we'll talk a bit about that later. Then it moves up and passes through that line of sight. We're going to call that our initial intersect, or the range that most of us zero at. Then it's going to continue up, and it's going to reach a point, a terminal ordinate, or maximum distance over our line of sight, and then start back down relative to our line of sight. and then it's going to pass back through our line of sight towards our terminal intersect. For most of us, this is a theoretical zero, because a lot of us live our life at a 25 meter or 50 meter range, and that's all we do. Is we do a bunch of cool guy shooting where we do up drills and we never really get past that distance. If you never shoot at that distance, that's your theoretical intersect. That's your theoretical zero. Okay, you may say you have a 25, 300 meter zero, but if you only shoot it at 25 meters and never confirm it out at 300 meters, that 300 meter intersect is theoretical. It doesn't become true until we actually punch some holes through and confirm it. Well, just consider that. Now let's have a look at this chart. This kind of represents what I'm talking about when I say standardized zeros don't really work out for us. Okay, we can see that these different barrel lengths shooting the same ammunition have drastically different muzzle velocities. And that's because factory ammunition is designed to perform out of a certain length of barrel. Most civilian factory ammunition is test fired out of a 20-inch blank barrel. That's very important because the rate of burn, or the time it takes for that powder, the propellant in the cartridge to burn, is based off of that barrel length. Meaning, when the bullet leaves the cartridge and starts continuing down the barrel, the powder isn't consumed instantly. Okay, that would cause a huge spike in chamber pressure. So it's designed to burn at a specific period of time, ideally just before it leaves the barrel. Because powder that's burned after the bullet leaves the barrel isn't providing any pressure or velocity increase towards the bullet, right? So as we start to bring our barrel lengths in, especially to the distance that we have an SBR, a short-barreled rifle, like a 10-inch barrel, what's happening is this bullet's leaving the barrel before this powder has the chance to burn all the way. So you're getting a lot of muzzle flash, and that powder's doing nothing to increase the velocity of the round. So you're getting a drastically slower round. A slower round directly equates to increased bullet drop at range because it's moving slower. So it has less chance to cover as much distance in the same amount of time as a faster moving round. That's why we get increased drop. And that's why a lot of these standardized zeros don't exactly work out for the setups that we're using. Okay? So we got a process that I use to figure out a custom zero that's going to work best for your equipment and your ammunition. And that's what we're going to cover in this section. Welcome back. Let's discuss some equipment that can make this process a lot more efficient and give you much more valuable data from the process. Like I said before, none of this equipment's mandatory. It's just going to help you do your job and do it a lot better. So first, let's talk about these two items I've got here on the side. These are ballistic chronographs. What they do is they measure velocity of the round coming out of the rifle. It's one of the most important data points to get from your rifle, and you can use that to really refine your zero process. It also gives you a great measure to see the consistency of your ammunition and the quality of it. You can do this for different batches of ammunition and keep that data for reference. So over here, we've got the Betamaster Chrono. This is the first chronograph that I used, and it gets the job done. It really folds into a nice compact area, so it's easy to take to the range, and it's cheap. When I say cheap, it's without the printer, it's at or less than $100, and it comes with a remote display. The printer tacks on just a little bit more. It's not too much. The printer does bring a lot to the table in that you can print out that data and keep it, or you can print out that data and throw it into your ammo cans if you've got different lots of ammo that you shoot, so you know what performance that ammunition is doing out of your weapon. You could even do it for multiple weapons if you want and just label it. So it's a nice tool. I've recently switched away from it because I've found that this device is a little bit temperamental. The printer doesn't always work when I want. Sometimes it just prints out of the blue, and it just isn't quite as user-friendly, I found. Now, over here on the left, we've got a more expensive piece of equipment. This is the Oler 35P. Now, like I said, it is a bit more expensive, but I've been extremely happy with this piece of gear. It truly is just plug and play. It's very simple. It's just got a few buttons, and it just does what you want it to. The only drawback with it is you can see it's up on these stands, these tripods. It's really kind of designed for bench rest shooters. Of course, I could use a training barricade over here to get some elevation on it, but I like it to be a bit more secure when I shoot. So I actually have a PVC pipe ground stand that I just made myself, and it works just fine. I can set it at ground level and shoot it in the prone. But it's a really great piece of equipment. Now of note, these items here, they can be a bit more pricey. One thing to think about, if you're shooting with a group, a club, you've got some friends or some neighbors that are into this, there's no reason you guys can't go in on one piece of equipment together and just split the costs. Because this isn't a piece of equipment that you're going to constantly use. Generally I use them when I get new lots of ammunition, different seasons, or things like that, and I want to get some data on that. Then I pull them out. Or I want to confirm some data. So, it's something that you could cost share on, just an option out there. Now, of course, here in the center, we've seen this before. I've had this out. This is my shooting rest. It's got a little ball detent. There's a lot of them out there. I like pulling this out when I shoot through chronographs because I don't want an accident to happen and have a client shoot one of these things. They can be a little bit expensive to repair. Just these little stands here, the sky screens, aren't too bad, but if you actually put it around through one of the sensors, it gets a little pricey. So I also like to err on the side of safety and have something, really sturdy to rest the weapon on. If you've got a bench rest lead sled that you could use on the ground or something like that, those are also really good too. So something to think about. This is just a camera I've got set here so I can show you a nice picture of some of the smaller items that I've got. Now, the next piece of equipment, you may find a little controversial. A lot of people don't like to use these, but it's a laser bore light. I find laser bore lights to be very, very useful tools. I use them a lot. They've got a lot of applications. You can use these for dry fire. You can use them to help you zero your weapon. They're really nice. Remember back to our fundamentals class where I told you that the sights are there to reference where the barrel's pointed. Well, one thing this laser bore light does is it actually gives you a visual means to see fairly accurately where the barrel's pointed. So we can actually dope in our rifles pretty good without ever firing around through them. So when we go to the range, we're just doing a little bit of fine tuning or confirming our velocity data, to get good data on our weapons. They're also really good for dry fire. There's a lot of dry fire drills that you can do with them. Now, the specific model that I have here is actually the military model. It's made by Insight Technologies, I believe L3 now, and it's the LBS 300C. I've used a bunch of different bore sight modules. I've used some other brands. I've used models that were breech inserted, and this here is one of the more accurate ones I found. There's probably a reason that the military uses them. They can be a little bit difficult to pick up. I actually found this one on eBay. It was only $80, and it really serves its purpose. It comes with a number of different dowel rods from 5.56, 7.62, and even 50 caliber. It has a string here that is designed to give you the proper distance to bore light from. Now, granted, that's with standardized ammunition and standardized rifles, so that's Army speak. If you're shooting Army ammunition and M4 rifles, that'll work for you. I'll actually show you the process to find out your specific distance. But yeah, really good, useful piece of equipment. So something to think about, if you want to make a purchase, or that could be something that you could go in with some friends on. Now, of course, we want to have some items to actually adjust our sights with. So you've already seen the Leatherman that I use here, the Leatherman Mutt. There's a few others out there. Gerber has a really nice one. Unfortunately, it's restricted, so you do have to have certificate letters to get a hold of them. You may be able to find some that fell off the truck on eBay, but this one serves its purpose, and it's got enough adjustments here to be able to deal with my weapon out on the range. So it's a nice piece to have on your belt kit. Now, another couple pieces of tools here that I've got. I've got this range tool, and I actually found this on Facebook. It's from a company called Grunt Style, and they make them. It's pretty handy. The center ring is designed as a reference for what the acceptable shot group size should be when you're zeroing and grouping. And it's got a tool here to actually be able to press down on your mechanical front sight, which works well. A bottle opener, I don't recommend drinking alcohol out on the range, but afterwards you might find it helpful. And then I've got a front sight tool. Now, this one is specifically designed for the iron sights I use. Remember, I use the Troy Industries diamond aperture sights, and they're also tritium. So this is a special tool that's designed to actually raise and lower the front sight and adjust the rear sight. So yeah, it's a nice tool to have out on the range. The next thing that I like to use here are some tools to help get you data for the distance that you're going to zero from and set your chronographs at. Whenever you're using chronographs, it's very important to have a precise form of measurement from the muzzle to where you're taking the measurements from. So, of course, we've got the low-tech, just regular old yard tape measure, and these are great to have on the range. If you wind up at a shooting area that doesn't have specified yard markers, it's quick and easy to take. That doesn't take any batteries, so it's not going to fail on you. A bit more on the high-tech side is I've got some laser rangefinders. I find these pretty useful in multiple different scenarios. Whether I'm at close range trying to find a specific yard marker, say I actually want to zero my rifle at 48 yards. Okay, I can do this pretty quick and easy, and I can do it by myself. It doesn't require me to actually have to stake down one end of the tape measure or have someone hold another end. So, pretty useful. The first one that I ever used was this item right here, and it's from Bushnell. Hey, it said it was good out to 1,000 meters, and it's camouflaged. Tough to go wrong with that. I did find that this item was a little unreliable out past 270 yards when you've got a lot of trees around. I had a lot of issues on some private land actually finding distances out to that range when I'm dealing with heavy brush. So I kind of made the switch after that to this one from Leica. Cost a little bit more, but the performance was really good. And if you look on the internet, it gets really great views. This, from what I've seen, this is easily capable out to the ranges that it advertises at. And I haven't had any issues with this piece of gear yet. So, it's always good to do some research before you lay down some money. You may find other uses for laser rangefinders too if you're a hunter. So just some things to think about. Now, of course, we got a GPS. Now, where a GPS comes in isn't really its strong suit in finding distances to targets. Of course, you could mark a grid and then mark a grid to where you are and then mark a grid to the target. But the little bit of error you get in there isn't going to be quite precise enough to do that. But one thing it can do is it can get you the GPS elevation to where you're at, so you can check your ballistic data. So there's some applications with that. Also, if you're training out in a remote area, it's always good to be able to get a grid in case you have to call in for, life flight in case something catastrophic happens. The next thing I've got here is a Kestrel. Now, this model actually does a few things. It gives me the temperature, it gives me wind speed, and it does barometric pressure. So these are kind of useful tools when you're out on the range. If you need to judge crosswinds, you can plug into your calculator. You can do that. You can put in the temperature and relative humidity. All of these things are going to affect the external ballistics of the round. So it's good data to have. Also, what I've got on mine is a card that tells me the heat categories. One of the things that we tend to do when we're out in the elements here is, we forget to hydrate properly. We forget to take breaks when we're shooting. Remember, this is a learning process that we're doing. It's good to push ourselves in certain situations, but when we do push ourselves to limits, it can be difficult at that point to absorb information. So there's a time to push ourselves, and there's time to be smart with it. It's when you really want to take in that information and learn, you really want to make sure that you're doing things properly. So these are really great guidelines to have on hand to make sure you're not exceeding those limits when you're actually trying to take things in. And then I've just got a small set of, these are really cheap binoculars, but they're small enough that they fit in a pocket or pouch. So if I want to take some a closer look at a target or things like that, I can do that. Of course, you could use a more expensive spotting scope, but they're a bit more bulky, and I haven't had the need for them lately. Now, the other thing that I have here is an iPad. And the reason I've got an iPad here is I use this for my ballistic calculator. And the app that I use currently is called Ballistic. I've been extremely happy with this app. It does everything I've needed, and I've tried the majority of the apps that are out there on the App Store. Now, of course, there's some free web-based ones, like the JBM Ballistic Calculator that you could use. The only problem is you need an active internet connection. I can use this one offline if I need to, but if I do have access to a cell signal, it will actually pull in weather and light data from the surrounding airports or weather services. So it'll automatically plug in my barometric pressure, temperature outside. It'll use the built-in GPS to get me my elevation. I can even figure out slant range from the angle that I'm using it at. One of the other really neat features, and we'll see this later when I go through it, is I can actually wirelessly print a range card from this thing, or I can email it. So if I'm out on the range and I want to email myself a range card, or I want to print it out on the spot or at home, I can do that. And I find that to be really useful. It'll print out in a nice small card that you can laminate. You can tape it to your buttstock or stick it in your pocket. So a bunch of different equipment here. And like I said, none of this gear that we have here is mandatory. Of course, we could do the old traditional method where we just go to the range and start punching through some holes in the paper. These are just enhancers that will help us get a better idea of exactly what our round is doing, and it'll give us quite a bit more data back and reference material to be able to make better decisions where we're going to place that round out at range. So some things to think about.